How do you walk? No, seriously. I want you to think about it. How do you walk? It's probably been a while since you've thought about how you place one foot in front of another. But before we can explore how you walk and how people walk, I need to explain how walking works. Turns out there's a lot more to walking than just walking. What is walking? For most mammals, walking involves physics. Walking is the use of a pendular motion created with our legs to propel us forward. Jokes aside, it is a pendular motion. The pendulums are located in our hips, our knees, and even our ankles. This cycle of swinging our leg and then our foot forward is the basic mechanical motion of how we walk. This pendular motion is great for conserving energy, that being our literal metabolic energy, by reducing the amount of strain placed on the muscles and tendons within our legs. Compare your normal walking stride to attempting to bunny hop everywhere. Your legs get quite tired after a while, since our bodies simply weren't designed with hopping around everywhere in mind. Well, turns out there's different ways to walk. There's axial driven locomotion, like lizards and gators, and they essentially take their front leg and throw it forward so that they can increase the size of their stride as much as possible. Humans, on the other hand, are appendicular driven locomotors. Appendicular driven locomotion is mostly powered through our limbs, like in cheetahs, where they use their front and their back legs. Now, on to how humans walk. Humans tend to use hip powered or ankle powered strides, where essentially the origin of the pendular motion that we talked about earlier changes depending on whether the person is using their hips to power their steps or the lever action of our feet and ankle to power their steps. Comparing these is like comparing how Skyrim NPCs walk to the way Oblivion NPCs walk. Did you spot the difference? Other ways humans walk can include forms of hip-powered locomotions, like catwalks and speed walking, but those aren't the focus of today's video essay. There's other ways of walking, like ungulate walk. Ungulate? Ungulate?
Ungulate, ungulate,
Ungulate walkers, where they're kind of just walking on one big tippy toe. Then there's plantigrade walkers, which is like elephants, where they're kind of stepping on the whole bottom of their foot at one time. There's also, of course, many other ways of locomotion. Just look at even our household pets. They're still engaging in some form of pendular motion, but they all have to walk differently, like cats, where they're like tippy toe walkers. But today, we're focused on humans. What is the best way to walk as a human? One study, published in the Journal of Experimental Biology in January of this year, sought to answer this question. Researchers Negan Falla and Owen Beck from U Austin conducted a study comparing energy consumption between hip-powered and ankle-powered walking. Prior studies had already determined that older adults, like 65 and up, engaged more in hip-powered walking compared to younger adults who primarily engaged in ankle-powered walking. Prior studies had also found that older people burn way more calories while walking. They have a way higher metabolic output compared to younger people. This was generally chalked up to, them being old, but Reagan and Owen wanted to dive a bit deeper than just that. They gathered 10 test subjects, 6 male and 4 female, all around the age of 25 with no prior musculoskeletal injuries, and ran a bunch of tests on them. These tests were, frankly, pretty ridiculous looking. Participants essentially were put in this leg brace that would measure the electrical output of their muscles, and they had this little oxygen mask on to track the CO2 output to measure their metabolic rate. Participants had to lay down and engage in motions according to the screen next to them, where they pendulated either their leg or their hips to the beat of a metronome. What was found? Yeah, hip-powered movement sure does require a lot more energy than ankle-powered movement. In fact, the study states directly, and I quote, every 1 nanometer increase in net joint movement required 31% more metabolic power at the hip versus the ankle. To put it in English, it required a shitload more energy to move the hip even a nanometer compared to the ankle. This is because, frankly, the muscles attached to the hips are simply a lot larger compared to those attached to the ankle. That, combined with hip extensors having significantly higher ATP consumption compared to ankles, means that hip-powered walking is a lot more metabolically intensive. If you need a quick refresher on what ATP is, you know how mitochondria are called the powerhouse of the cell, and then you learn that and you kind of forget everything else that they do? Yeah, that's because they produce ATP, which is generally used to power muscle movements. Using ATP or engaging in metabolic activity is what causes you to burn calories. Ankle-powered walking, on the flip side, has the potential to be as energy expensive as hip-powered walking, since the lever that your foot is operating on is a lot smaller than, your body itself. This is generally alleviated with the power of tendons. Tendons are a heck of a lot more energy efficient compared to muscles, and they're more able to recycle energy because they're stretchy, kind of like a pendulum in and of themselves. They swing the energy back and forth where it's needed, like a tennis match. So, if hip powered walking sucks so much compared to ankle powered walking, why do old people do it? Well, simply put, it puts way less strain on smaller tendons and ligaments in the legs. You know, shin splints? Yeah, hip powered walking could alleviate them. Plantar fasciitis? Yeah, hip powered walking could help with that too. So, why research this at all? Well, on one hand, yeah, it's kind of just really cool. Have you ever seen those goofy videos of those robot dogs that are moving and dancing? Studying the methods behind movement can allow us to make more efficient energy wise, but also more balanced robots. Worry not, though. Even if you're in your AI robot hating arc right now, due to everything that's going on with AI and art, this technology can still help us humans through prosthetics and even full-fledged robotic limbs once we get down to the real nitty-gritty of the mechanics of locomotion. This is also hugely beneficial for rehabilitation purposes, like physical therapy or post-surgery. For example, you know Dr. House? The guy with the limp in all those YouTube shorts? He has a thigh injury from an infarction, or a blood clot that caused some of the muscle in his thigh to die. While researching for this video, I had to look up whether or not hip-powered walking would actually help with his pain. Turns out hip-powered walking would be terrible for Dr. House, because it could potentially put more strain on his injured leg, which would inevitably lead to worse injury. Reasons like this are exactly why the mechanics of locomotion and the biology behind locomotion needs to be studied to ensure that we can help people. Hi, post-editing Emma here. I just want to give a few very important shout-outs. First and foremost, I want to shout out my lab partners, Avani, Peter, and Liberty. They all not only helped me get footage for this video, but they also provided tremendous emotional support throughout the whole process. I want to shout out my cat. He did nothing to edit the video. He was just kind of there and did his job as an emotional support animal. I want to shout out my Prozac for keeping me sane during this entire process. I want to shout out Dr. Burns for providing me with the valuable understanding that being a YouTuber is not a realistic backup option. And I need to shout out the same one stock footage website that I used the entire time. Don't remember what it was called. Let me Google. But same one stock footage website that I used for this entire process. and ChatGPT for also providing me with emotional support and reminding me to sound like a human instead of pausing every 5 seconds like I have here. So yeah, this was a huge process. First ever real video I've actually made. I don't want to ever do it again.